Today we'll build a full-stack chatbot in Node.js using OpenAI's GPT-4o mini model from GitHub Models. We'll create a backend API for conversation handling and a user-friendly front-end interface for chatting. Let's get started. To start, first set up a new Node.js project and install the required packages. We'll use Express to set up our web server and OpenAI to interact with OpenAI's API. We'll also grab some environment variables using .env. Once you have these packages installed, create .env file to securely store your GitHub API token. Now let's set up the backend server. We'll configure Express and create a post endpoint chat to send messages to GPT-4o mini. We'll also maintain a chat history to make the conversation flow naturally. First, initialize the Express server and import required modules. We start by importing necessary modules and setting up the port our server will listen on, process.env.port if specified, otherwise 3000. Then, we grab our secret API key from the environment variable GitHub token. We'll use this later to talk to OpenAI. Next, we define the endpoint URL for our AI model and the model name we want to use, GPT-4o mini. This is the secret sauce of our chatbot, the GPT-4o mini model, capable of generating human-like text in response to a prompt. Now that we have our tools and configurations, let's create our Express app. We'll use Express to create an instance of an Express.js application. We'll also configure our app to handle JSON data and serve static files from the public directory. This is useful to serve an HTML page to interact with our chatbot. Now, the fun part, creating the chatbot. We'll initialize the OpenAI client with our endpoint URL and API key. This lets us talk to OpenAI's API and query the GPT-4o mini model. We'll also store the conversation history between our user and the chatbot in an array called chat history. This will help the model understand the context of the conversation and provide more relevant responses. Alright, let's define a route for our chatbot. This route handles post requests to the chat endpoint, which is probably where our HTML form will send messages to. Inside this route, we'll first grab the user's message from the request body. This is what the user typed into our chatbot interface. We'll then add the user's message to our chat history array. Remember, we want the model to consider the conversation history when responding. Now comes the magic. We'll use the OpenAI client to call the chat.completions.createAPI endpoint. This fancy function sends our chat history, including the user's message, to the GPT-4o mini model and asks it to generate a response. We'll also provide the model name to tell it which model to use for generating the response. The response from the API will include a list of possible completions, text continuations, for our conversation. We'll grab the first completion, which should be the best response according to the model. We'll then add this AI-generated response to our chat history as well. This way, the model can consider its own response in the next turn of the conversation. For debugging purposes, let's print the entire chat history to the console. This can be helpful to see how the conversation unfolds. Finally, we'll send the AI-generated response back to the client. This will be displayed to the user in our chatbot interface. If there's an error while calling the OpenAI API, we'll catch it and send an error message back to the client. The last step is to start our server. That's it. Our server is ready. Now, let's build a simple front-end UI for our chatbot. Create an index.html file with a chat interface and JavaScript code to handle message display and sending user input to the backend. In index.html file, create the HTML layout. This layout includes a chat container division for displaying messages and an input field with a send button. We'll use JavaScript to handle the messaging. I have also added some CSS to make the UI nice. Now implement the JavaScript to handle sending messages and updating the chat UI. First, grab the references to the HTML elements where the user types their message, user input, and where the chat conversation is displayed, chat container. Then, it retrieves the user's message from the user input field. Add a quick check. If the user didn't actually type anything, just spaces or nothing at all, the function simply returns, preventing unnecessary actions. Next, we want to display the user's message on the screen. We create a new HTML element with the class messageUser to style it as a user message. We set the text content of this element to the user message and then add it to the chat container. Finally, we clear the user input field for the next message. Now comes the part where we send the message to our server. We use the fetch function to make a post request to the chat endpoint we defined in our Node.js code. The fetch function takes an object with options for the request. We specify the method as post because we're sending data to the server. We also include a headers object to tell the server that we're sending JSON data. Finally, we use JSON.stringify to convert the user message into a JSON string, which is how the server expects to receive it. After sending the request, we use a waitResponse.json to wait for the server's response, and then parse the JSON data received from the server. Now we display the assistant's reply on the screen. We create another element with the class MessageBot to style it as a message from the chatbot. We set the text content of this element to the data.reply, the response from the server, and add it to the chat container. Finally, we scroll the chat container to the bottom so that the latest messages are always visible to the user. And that's it. This sendMessage function handles the core logic of sending user messages to the server and displaying the conversation flow within the chat interface. We've just built a real-time conversational AI chatbot in Node.js using OpenAI's GPT-4o Mini. This setup demonstrates how you can create a multi-turn conversation with an AI model using Node.js, Express, and a simple front-end. You can easily expand this project by adding more UI elements or even deploying it for wider use. If you enjoyed this video, you will definitely love to watch other quick coding challenges on this channel. See you in the next video, and happy coding!